Yeah, good afternoon. Here from Haarlem in the Netherlands. Same time zone as you in Luxembourg, I think. And so I'm going to talk about developing the RIPE routing information service. And so for people who don't know the organization I work for, which is the RIPE NCC, if you know us, you probably know us from registering IP addresses, autonomous system numbers, which is a primary function that we do. And apart from that, we also have a couple of information services for the good of the internet. One of them is called RIPE Atlas, that you might know, and the other one is called, or another one is called RIPE RIS, and that's what I'm specifically going to talk about today. So if you can go to the next slide. So first of all, what is RIS? Routing Information System, but what does that actually mean? RIS collects BGP data from a diverse set of networks on the internet. So BGP is the air traffic control of the internet. It is the protocol that allows networks to exchange information about how data is routed, how your packets are routed, and that's the explanation for the non-network operators, because they probably all know this. So it's very important to actually, well, a network operator has a good view of their own network, but outside of your network, it's a little harder to get information about how is the internet actually behaving. And that's what this platform, our Route Collector project, actually aims to provide this insight. So we have many interfaces. If you go to ris.ripe.net, that's like the main site where you learn more about this project. And one of them is called RIPEStat, or actually, RIPEStat is something that provides you with a lot of specific views into the data that we collect. Another one is called RIS Live, where you get a live feed of the data we collect. And there's also raw data. So if you like to, if you have, for instance, a post-mortem of a network event you want to do, then it might be useful to actually look at the raw data to actually see, or develop tools on top of the raw data to actually see how a particular event on the internet actually went. We do analysis of particularly big things that happen on the internet. We put that on a platform called RIPE Labs, labs.ripe.net. And as a segue, if any of you have really interesting content that you think is interesting for the wider community, then we'd be happy to take contributions from all of our people that have this from all parts of our service region and beyond. And as a particular example, the RPKI system that aims to protect or to be a building block for protecting internet routing infrastructure, we use our RIS data to provide statistics on that. Conceptually, you can actually see this system as something that shines a light onto internet routing. So imagine you see your own network, but the rest of the world is black, and this or it's dark, and this actually gives you vantage points to actually see what's going on in the rest of the internet. And one of the things why this just having systems like this in place is important is that it makes it harder to do malicious things on the internet. In a dark street, there is more crime than in a street that is lighted, because it's easier to get detected and noticed when there's this light shining. So that's like one way to conceptually, if you don't know what the technical details are, I think that's a nice takeaway from what systems like this do for the internet. Can we go to the next slide? So we do this by means of route collectors. We have 24 physical machines distributed across the internet, and I'll show a map later. And many of these are at internet exchange points, and we actually collect data from the peers at these internet exchange points. So we have some at the three biggest European exchanges, for instance. We have short and reliable path to our peers. The peers are so the vantage points where we actually collect this data, and we have 18 of these collectors around the world. We also have 2 multi-hub collectors, which are in Amsterdam and Montevideo. Montevideo is actually with our sister organization, LUNOG3, for the Latin America region. And there we actually have sessions from all across, in the LUNOG3 case, from their service region, and from the other one, we have sessions from all across the world that actually feed us data from particular locations. So we have a lot of vantage points on the internet. But the bad or the downside of having these types of collectors is that they sometimes have very long connections to our infrastructure, which sometimes makes them less reliable and stable. So can we go to the next slide? Yeah, I told you about RipeStat, and this is kind of a segue, but it's what RipeStat is a one-stop shop for a lot of data about IP networking. And a lot of the data that is represented there is based on the raw data we collect in our RIS system. If you want to go there and check it out, it's stat.ripe.net. And what you can do there is you can put in your own IP address, your own prefix, and it will give you a lot of information around geolocation and the database, who the abuse contacts are, things like that. And a lot of the data in here is around routing data is based on this. So you have visualizations, and the most famous one, which we have a picture of here, is called a BGPlay, where you put in an IP address and a time range, and it will actually show you exactly what we can see on the internet on how routes change. So if your network goes via A or via B, or and in case of incidents, this is really useful to actually see what happens there. There is a JSON-based data API that underlies these. So if you want to play around more with the data underlying these, the data is available through RipeStat. If we can go to the next slide, please. So the next interface I want to talk about is called RIS Live, and this is actually a real-time public feed of BGP updates. So, and this is actually the data we get in. We usually, within seconds, we can actually feed it towards anybody who wants to consume this. And this is more tailored to like the real-time use case, where if you want to detect a BGP hijack, for instance, and I'll talk about a little bit more about that later, this allows you to detect that. This gives you the raw data to do the detection on within seconds. So that's pretty cool. It's a JSON over WebSocket, so it's convenient for developers, and you can do a lot of filtering on this, because what you actually can do is get the full fire hose of data, which is quite a lot of data streamed at you. And this is open for third-party utilities. So this is anybody can develop their application on top of this. And a very good example of this is something that the people at NTT did, which is called BGP Alerter. Where if you fill out a config file and run this particular piece of software for your network, you will actually be in near real time be alerted when something strange happens on the internet related to the things that you're monitoring. So if somebody announces a more specific prefix to your prefix sets, things like that. So that's a very good example that, and as you can see, the data that we collect in our RIS routing information system is we develop interfaces on top of that, so you can actually see what's going on via interfaces that we develop, and it's also open for third party for people external to the right entity to develop their own software. So we hope to have a thriving ecosystem of things where we provide useful data about the state of the internet. That's sort of like the higher level goal there. If we can go to the next slide. So I talked about these route collectors, but where are they physically? So if, and maybe this is a little too small, the dots on here are actually the locations of these route collector systems. But if you actually look at the physical locations, specifically for these multi-hops, if we go to the next slide, there's a picture of, yes, thank you, where they are, and we also colored the countries, and that gives a, well, it's a much broader, as you can see, we collect from more places, if you look at it like that. You can also see where we don't collect yet, and has our specific focus, and I'll talk a little bit about that later on. Well, if we want to shine a light on the whole internet, we should probably also collect data that is representative of more of the internet. Next slide, please. And here's like, I myself, I'm a data analyst, and it's great to have more data. And as you can see, in the beginning of 2019, we had 1.4 gigs of data, and this data is a particular snapshot of the routing table we collect. So we have hundreds of full feed peers, and the v4 table is currently over 800,000 prefixes. So that is, I think it was 300 million routes that represents. And to the right, you actually see that by the beginning of this year, we grew that to 2.4 gigs. So that's great. We have more data. But the downside is, if you want to do analysis of the whole data set, it takes twice as long. So so this got our thinking, and this is also, we provide a lot of this data to external people for further analysis, and for them it also takes twice as long to do this analysis. And you want a low barrier to entry to data like this, and a low cost of development. And a development cycle with this much data is, I can tell you from personal experience, it's sometimes it gets a bit complicated. So if you can go to the next slide. So I started looking at the diversity in the vantage points that we have, and thinking that if some of the vantage points provide very similar data to us, then we probably don't have to collect or analyze the data coming from them and provide the same type of picture with less data to people. So there's on our RIPE Labs platform, there's a post about this. The URL is there. And what you see in these pictures for IPv4 and IPv6 is sort of the footprint in diversity that we have. The rows and the columns are, each row and each column is a vantage point. So one of the full feeds where we get a full internet table. And this compares them to each other, like how different are they? And as you can see, well, there's quite a lot of similarity in terms of the links in between autonomous systems that they see. If you look at the left, there's some lines in there, lighter lines of peers that are significantly different from the rest, and these are the ones that are probably most interesting in. They provide you a different feed of the internet, a different view of the internet. So it's probably interesting to have more of these in our data. In IPv6, there's a bit of a different picture, and that's actually due to the split between Cogent and Hurricane Electric, who are not peering in IPv6, at least not when I did this picture. And you see there's a lot more variation there or actually kind of a black-white pattern. There's only two types of feeds if you look at it this way. If you can go to the next slide. So if you look at that last picture, that got us thinking into like redundancy in the data. That's not very nice. If you provide data, then to people, everybody has to weed out these redundancies. And so in our visualizations and in our streaming of data to people, redundancy actually means, in visualization, it means that you just show more on the screen than is necessary. And so if you can show the same signal with less of this noise, that's a better visualization. It gives people an easier way to gain insight into your data. And for the case of live streaming, it means if you provide them with less data that has the same signal, it's also better because you can serve more clients with the same amount of resources. And it's also got us thinking about the expansion model for this. Do we want to add the route collectors at IXPs, or do we want to add these multi-hops? Because they probably provide a more diverse set of data. And so what we are really looking for is strategies for better diversity, less data processing, more signal, and a shorter time to insight. So if we can go to the next slide. So as I said, BGP hijacks is a good example of why this diversity is useful. If all the views are very similar, you will have an all or nothing signal. And if we have more diverse feeds, we'll be able to see hijacks that are currently flying under the radar, especially in areas where we don't cover. We don't know if there's hijacks there or not unless we start covering these areas. And currently we are on average 2.7 AS hops away from all of the prefixes on the internet with WIS. But it also means that there's more than 2 decision processes on average within networks on propagating a route or not, which make us maybe not see as much as we could. So we would like to find the way of peering with people where we get this type of diversity that is useful for specific use cases like BGP hijacks. If you can go to the next slide. So the key challenge here is capturing diverse data while keeping the data volume in check. And we want peering coordinator and to link this to your local community. I'd be really interested to hear in questions or in comments later. My email address is on the slides. How to make this more useful to internet operations in Luxembourg. Are people using our systems? Or what specific use cases are missing, and what would you want to see from this? So can we go to the next slide? An idea I was toying with is, can we get our information system covering all the networks that are have significant user populations in a country? And this is a screenshot I have of the estimated user populations of networks in Luxembourg, well, we cover one of them. We cover the upstreams of these networks quite well, but do we also need to peer with networks in that have these significant populations themselves? So we could actually see the effect of hijacks and stuff like that for specific user populations. That's one way we could actually go if we started peering with specific networks in countries. If you can go to the next slide. So we are developing this peering strategy right now. So input from our community, and that includes NOGs, LUNOG, and any other NOG. Input here is appreciated. What should we focus on? We would like tier one networks, so the very big networks are obvious. We have many of them, but not all. Do we focus on locally influential networks? end user networks? Do we focus on areas that have high interconnect densities, so IXPs? Will we collect route servers? Do we collect local tables? These are all open questions to us, and that we would love input on. So if we can go to the next slide. Well, I'd like to conclude with this. We have a system that is very much valued by our community. In our latest survey of our community, this was regarded as critical by many. And we would love to get into a conversation with our community on how we can provide more value to you out of this system. And the key challenge I see is growth versus insight, and what types of peers we add. And you can let us know at that email address, or if you go to the next slide, that has my email address on it.